is find out I of t for t greater than 0 when the switch is opened at t equal to 0. Here this is the switch and this is opened at t equal to 0. That means the configuration will be this like this, right? This is equal to t equal to 0, right? So is asking for the current I of t that is mentioned here. This is the current I for t greater than 0, right? So for solving this, first we have to solve the equation at t equal to 0 minus. That means solve the circuit at t equal to 0. At t equal to 0 minus, always the inductor is acting as a short circuit, because from minus infinity to 0 minus there will be one steady state for inductor. So that's why in the steady state always the inductor acts as a short circuit. And what is the switch position? At t equal to 0 means the switch is closed or open? Switch is closed, because at t equal to 0 switch is open. So that's why at t equal to 0 minus the switch is here closed. So if you solve the network t equal to 0 minus, we got, now I am drawing the network at t equal to 0 minus here. That will be here, this is 40 volts and the switch is open, closed, and so this is some voltage source, that is 10i, and this 20 ohms, right? So directly inductor acts as a short circuit. Now the 40 volts is directly present across the 20 volts, so that's why this is I of 0 minus. So I of 0 minus equal to 40 by 20, that is equal to 2 amps. This we know. Now at t equal to 0 minus the current through the inductor is 2 amperes. At t equal to 0 plus also, that means I of 0 plus is also the current through the inductor is similarly like at t equal to 0 minus, because the inductor is a property that it does not allow the sudden changes in current. So from 0 minus to 0 plus, the change in time is approximately 0. So that's why the inductor does not allow the sudden changes in current, whatever may be the circuit configuration. If you observe the circuit configuration at t equals 0 plus, this will be open. So the circuit will be simply like this. Means so like this, right? So but still the current is 2 amperes only. Now at t equal to infinity, we have to observe at t equal to infinity, the circuit will be something like this. There is no voltage source here because the switch is open. So this is the circuit at t equal to infinity. Is there any independent sources present in this network? No, nothing is there. So that's why the current I is equal to here 0. So at t equal to infinity, the current I equal to 0, but at t equal to 0 minus, the current equal to 2 amperes. At t equal to 0 plus also, the current equal to 2 amperes. And we know that the formula for the current I of t is equal to, the formula for current I of t equal to final value minus final value minus initial value into e power minus t by tau. So that means the value of the current at I infinity is the final value minus I infinity minus I of 0 into e power minus t by tau, where tau is the time constant of the network, right? I am writing here, but tau equal to L by R equivalent. Now we have to find out R equivalent in this network. That is very important thing. If you want to find out the R equivalent, we have to observe the network at t equal to infinity, right? At t equal to infinity, the network will be this simply, right? And we have to look into the terminals of an inductance and we have to find out the impedance, right? Here this is a 10i source and this current is simply I, right? This is our 30 ohms and this is a 20 ohms, right? So this is the network at t equal to infinity. Now if you observe the network from the inductor terminal, then you have to find out what will be the resistance. Here this is a dependent source, that's why we can't short circuit the dependent source, because generally the procedure for finding the resistance between any terminals is, first we have to open circuit, first we have to kill the sources. The killing the sources means we have to short circuit the current voltage source and we have to open circuit the current source. That is the procedure. But here we don't short circuit this source because this is a dependent source, right? So that's why we are not short circuiting this. So if you observe a KVL here, or I can say one method is, if you apply a voltage here from this terminal, if you apply a voltage and find out the current I, then the V by I nothing but a impedance, because suppose an unknown network is given to you. This is an unknown network, Right. Now these are the two terminals of an unknown network. How to find out the resistance or impedance of this network? Because we don't know what is the inside of the network. So in that case, what we do, you just apply a voltage here and just find out the current here. Then V by I is nothing but an impedance of the network. In this manner, we are finding the unknown impedance of this network. So I am applying here a voltage called 10 volts. Okay. Now intentionally I am applying it 10 volts here. Now if you find out, if you apply KVL here, minus 10I plus 30 into I plus 20 into I is plus 10 equal to 0. Then what we will get here, minus, that means 40I equal to 10. That means I equal to 40I equal to minus 10. I equal to minus 10 by 40. That means I equal to minus 1 by 4. That means what is V by I? V by I nothing but an impedance, that is called R equivalent, that is equal to minus that equal to simply 10 by we are applying a voltage 10, so that is 10 equal to 10 by 1 by 4. That means 40 ohms is our impedance offered by this network. So the 40 ohms is impedance offered by this network, and we have to find out the final equation. I am writing the final equations here. Right. Now what is the value of tau here? Tau equal to L by R. L equal to what here? L is 2 and R equal to 40 we got, and that means we will get 1 by 20. Right. Now the formula is infinity value of the current is 0. I of t I am writing. I of t equal final value is 0 minus the final value is also 0. Again 2 the initial value, e to e power minus t by tau. That means 20 t. So from this what you will get? 2 into e power minus 20 t. So I of t equal to 2 into e power minus 20 t. In this way we have to find out. Here the first important thing is at t equal to 0 minus we have to find out the current, and then that current is nothing but t equal to 0 plus current, because the inductor does not allow the sudden changes in currents. And again we have to find out the infinite value of the current. Right, at infinity what is the current? That infinity, if you draw the circuit, there is no dependent voltage source in the network. This is the infinite, the diagram corresponds to infinity at t equal to infinity. Right, so here there is no dependent voltage source, independent voltage source. So obviously if there is no independent voltage source in this network, means the current through the network or voltage across any branch in the network is 0. So obviously the current is 0. So we conclude that at t equal to infinity the current I is 0. And after finding that, then we know that the formula for the current I at t greater than 0 is final value minus initial value into e power minus t by tau. Then here tau is L by R. Then the important thing is we have to find out the R equivalent. R equivalent can be found with the help of this method. Then we found that R equivalent equal to 40 ohms. Then we directly substitute in the equation. Then we got 2 into e power minus 22. So we have to go for option D. So this is our right option.
Question is, which of the following do not satisfy the wave equation? Here, if we observe the following functions, we can say that is satisfying the wave equation if it contains only the function of frequency as well as the axis of the propagation. But if we go to the option D, it is consists of square of the cos function, means it includes the DC term too. So it's not going to satisfy the wave equation. Hence the option D is the correct answer.
In this problem, it is given that z is equals to x plus jy, where j is a unit vector and x and y are real numbers. Now we have to find the value of modulus of e power jz. Now we know that z is given as x plus jy, so we will substitute them. That is equals to e power xj minus y, since j square is minus 1. Now this can be written as e power minus y into e power xj, which is equals to e power minus y into cos x plus j times of sin x. Now we know the formula e power I theta is nothing but cos theta plus I sin theta. Similarly, e power xj will be cos x plus j sin x. Now modulus of any real number is nothing but root over square of the first real number plus square of the coefficient of imaginary number, which is cos square x plus sin square x. Now that is nothing but e power minus y, which is option D.